There's only one section of it. You could have to do like lots and lots of sections of it, right? A whole chapter of it. I'm going back. I don't remember what I assigned 3 for. 3 through 19, 24, 27. Yeah. At least I didn't do like 3 through 45. I promise this is it. At least for me, Elijah, this is it on solving for 3 variables and 3 equations. I have not looked through all 1,000 pages, but I've looked through pretty many of them. Okay, we'll go ahead and get started. The first thing I want to mention is I sent out an email on Tuesday. I don't know what time it was. Was it during all the election craziness? I don't know. Anyway, 3.8, I have listed the homework as 3 through 9 odd, 13 through 17, and then I have 25 through 25 odd. So it's actually should be 25 through 35 odd. So if any of you have gotten to 3.8 yet, it should say 3.8. The last part should say 25 through 30, not 35 odd. So I just typed it in there, not just 25 through 25. That'd be kind of a weird assignment. All right, so does anybody have any questions that they wanted to go over? Why? Because math, that's why 3.4 is so hard. Elijah said, why is 3.4 so hard? I know it seems easy, but it's all those little math things, right? And I'm guilty of it too. Like when I did that example in class, I mistakenly subtracted something, and then that throws everything off. I know, even if you know how to do it, right? Okay. I believe I have every answer. I wish you could graph it. I know, there's no 3D calculator. Well, there probably is somewhere, but Desmos won't graph it for you. Yeah. I'm sure there is a 3D calculator. We just don't have it. So. Now, one option, as you're doing your homework, once you get it down to 2 equations with 2 variables, you know how we go from 3 equations with 3 variables to 2 equations with 2 variables. Once you get it to 2 equations with 2 variables, you can check your work with a 3D or with a regular calculator, right? And then once you're doing your work, at least you know you're on the right track. Okay, well, let's go ahead and get started. Greta, I wouldn't know if you spelled it wrong anyway. What I wanted to do today is start chapter 4. I'm just kidding. What I want to do today is go over the last 3 sections of chapter 3 again. So we went through all of these on class on Monday, and everyone, I think, started to get it, but I want to make sure that you really understand what you're doing. And today we're going to supplement with some calculator use for matrices too. So I did send out a link in the email to a website that I think is fairly decent at doing matrix calculations. So we'll be switching between that and our actual problem. So what I thought we could do is we could pick one of our problems that you have to do in 3.8 and go back through all of the things we had to do in 3.6 and, well, 3.6 really, I guess I should take a step back. Does anyone want to see again, 3.6 is how you multiply matrices by hand. Does anyone feel like they want to see that again? So that was just not when we got into all the determinant and inverse and all that, but this was just purely multiplying 2 matrices together. You're still in 3.4. So maybe we should do one from 3.6 just to refresh our memories about what we need to do to calculate that. How does that sound? Okay, let's do one from 3.6. Let's do, I have 3 through 17 odd, no calculator, 3, and then 23 through 29 odd, use calculator if needed. So let's actually do one from 23 through 29 odd where you can use your calculator, but I'm going to do it by hand and by calculator both. So we can review everything kind of all at once. Okay, so bunch of words to say. I'm on page 200 and I'm going to do problem number 25. So top of page 200. Problem number 25. Okay, so what we have along the top is we have a given matrices. So they give you matrix A, B, C, D, E, and yeah, A, B, C, D, and E. Okay, and what number 25 asks you is to multiply matrix A times matrix B and subtract that from matrix B times matrix A. Okay, so what we need to do is figure out what A and B matrices are, which is written right above there. So we can do that. So matrix A is 5, -3, -2, 4, if I can write correctly. And matrix B is 0, 1, 4, -2. So that's just the first part. This is A times B. And then we have minus B. Sorry for the messy writing. B times A. So the first thing I need to do when I write it down is make sure that I wrote everything down right, because that would be bad if we got to the end and I realized I wrote something wrong. Okay, so everything looks good. So the first, if you're doing this by hand without a calculator, which this one is entirely possible, it's just a little more complex, right? And this is what you're going to be doing in the earlier part of the section, is you're going to be multiplying. And what you need to think first off is, can these be multiplied? This is a pretty easy answer because this is a 2 by 2 matrix, and this is a 2 by 2 matrix. And since the number of columns in the first matches the rows in the second, then we can multiply and we're going to end up with another 2 by 2 matrix. Okay, so what are we going to end up with here? This part here, this is the position of this new matrix once we multiply. This is the first row and the first column. So in order to figure this out, we're going to multiply the first row times the first column. Okay, so this is the first row times the first column, and it's called a dot product. I'm going to erase those off of there just so we do that, but that's what we're going to do. So we're going to do 5 times 0 plus -3 times 4. So it's 5 times 0, -3 times 4. Okay, so this is kind of familiar. 5 times 0 is 0. -3 times 4 is -12. Right? Are we subtracting? No, Elijah, we're adding. We're adding together. When we do the dot matrix, we're adding together. But because this is a -3 times 4, and this is 0, so this becomes 0 plus -3 times +4, you get -12. So that's how we end up with a -12. What is the subtraction symbol then? So we have to add. Yeah, you have to add and then multiply the negative signs. Oh. Sorry, this subtraction one, Greta, thank you. The subtraction one there is going to happen afterwards. So just like numbers, we use the order of operations, we do the same thing here. So you have to do the multiplication before you do addition and subtraction, just like PEMDAS. So we're going to evaluate A times B first, and then we're going to evaluate B times A, and then we're going to subtract the two. Okay. So then to find the first row, second column, right? This is the first row, second column. We're going to multiply the first row times the second column. All right. I know you can do it, Elijah. So we're going to do 5 times 1 plus -3 times -2. So 5 times 1 is 5, plus -3 times -2 is +6, so we get 11. So then we get to this position, which is the second row, first column. So that's going to be multiply the second row times the first column, right? So that's going to be -2 times 0 plus 4 times 4. So 4 times 4 is 16, and this is 0, right? This cross each other off. It's Christmas colors. Okay, and then we've got the Christmas. Then we've got this last position, the orange position is the second row, second column. So that would be second row, second column. So we've got -2 times 1 plus 4 times -2. So -2 times 1 is -2 plus -8, which is going to give us -10. So that was just multiplying A times B. All right. So then we get to practice again by multiplying B times A. Same process, right? Let me see if I, all right. Yay. How do I make the eraser bigger? That kind of works. I know. I need a bigger eraser. Okay, so that was our first matrix. So we're going to do the next one the same exact way, right? We're going to, we know it's a 2 by 2 matrix by a 2 by 2. So we know it's going to end up with another 2 by 2. We've got that, right? So now we just have to do the same process. Okay, so to figure out this position, we need to, this is the first row, first column. So we're going to need to multiply by the first row times the first column, right? So that's 0 times 5 plus 1 times -2. 0 times 5 is out, so we've got 1 times -2 is -2. Thanks, Elijah. I know you guys would be more techie than me. Okay, so second or first row, second column. First row, second column is going to be 0 times -3. Let's make my screen a little bigger. 0 times -3 plus 1 times 4, Well, 0 times negative 3 is 0, so 1 times 4 is 4. Okay. Then we've got second row, first column. Second row, first column would be 4 times 5 plus negative 2 times negative 2. 4 times 5 is 20, plus 4 is 24. And then the last one that we're going to do is the second row, second column. So second row, second column would be 4 times negative 3 plus negative 2 times 4. So 4 times negative 3 is negative 12 plus negative 8, which is going to give us negative 20. All right, so you guys still following along? The screen looks crazy, right? Colors everywhere. You're not following along? This is just multiplying two matrices together. All right. So now we're almost, yes, it is crazy. So the last thing we need to do is subtract. And this is the easy part, right? This we just get to straight subtract if we even have room at the bottom of our screen. Okay, so we're going to do negative 12 minus negative 2. Oops. Okay, so negative 12 minus a negative 2, that's like adding 2 to negative 12, so negative 10. Okay, then we've got 11 minus 4. 11 minus 4, and I get 7. We've got 16 minus 24. So that's going to give me negative 8. And then we've got 10 minus a negative 20. So that's like adding 20, so I get positive 10. So the goal of this entire equation is, yes, that's the goal. But first, before we could subtract them, we had to multiply them, right? And the multiplying part is what you have to do in, let me look at the problems again. 3 through 17 without your calculator. You got to know how to calculate it. And then here we get to use our calculator. But I wanted to show you because you get, do two things at once, right? Okay, so now let's switch over to the calculator. You're like, thank goodness, right? So this is the best matrix calculator I could find. So let's just clear out whatever was in there. Okay, so what we have, and conveniently, they're named matrix A and matrix B. That's what I was going to say, Elijah. Kill two birds with one stone. Conveniently, they're named matrix A and matrix B. It's not always going to work that way. So let me just show you. Yes, whoa, right? There's a lot you can do with matrices. We're just kind of touching the top level of it, right? Yeah, there's all kinds of matrices. We're just going to keep it pretty simple here. So the basics here is that we want to have a 2 by 2 matrix, right? So we can make this a smaller matrix and this a smaller matrix. So that's not too bad, right? So what we can do is, again, conveniently, we're working with A and B. So we can do 5, negative 3, negative 2, and 4. This is the original matrix A, right? And then our original matrix B was 0, 1, 4, negative 2, right? All right, so we have lots of different things that we can do, but we're going to use basically these functions here. So you've got A times B, and then you have a place here where you can type in your own equation. So those are the two places that we're going to use. We can find the determinant and the inverse, so we might use those. After that, some of these I'm not even quite sure what they are. So to be completely honest. So the first thing what we want to do is we want to find A times B. So let's check our work. A times B, and then the calculation comes up down here. A times B is negative 12, 11, 16, negative 10. So let's switch back here. Negative 12, 11, 16, negative 10. So we did A times B correctly. Phew, right? Okay, so the next thing I want to do is check my B times A. So I can type that in here and do B times A. This is way easier, right? Oh, that didn't work. Maybe it has to be capital B. Capital B times capital A. There we go. Okay, so we get negative 2, 4, 24, negative 20. Negative 2, 4, 24, negative 20. Okay, so that we did that right? Right? So we've checked this matrix, check this matrix. Now we need to subtract the two. So we don't want just A minus B, right? The actual equation of what we're doing is A times B minus B times A. Okay, so it actually shows you matrix A times matrix B minus matrix B times matrix A. And we end up with negative 10, 7, negative 8, positive 10. So let's switch back here. Negative 10, I can't remember even my numbers. Let me just minimize because my brain's not working. Okay, there we go. Here's what we came up with. Negative 10, 7, negative 8, positive 10. So now you guys are like, why did you not just show me the calculator first, right? Instead of what everyone's thinking at home. So there is powerful calculators out there, right? But I do want you to know how to multiply matrices together. That's not too hard to do. And I did say that you could use your calculator for these problems. But like I said, Elijah and I both said, kill two birds with one stone, right? So that is 3.6, and that is a little bit of an introduction to a matrix calculator and how that can be powerful. Anybody have any questions about that? Are you all playing with the calculator right now? Okay. I don't want you to think of the massive amount of math you have to do. All right, so let's keep trudging through so that you guys can get out of here by 10. Okay. So I want to kind of now with 3.7 and 3.8, I want to not jump around a ton, but jump around a little bit. So the main point of doing all of this pain with matrices and why are we doing this and all that is actually to make you is actually to help you solve equations like in 3.4 using a calculator. All right, and that's a matrix calculator. So we're going to kind of work backwards. So what we talked about in class on Monday was that if we have like a system of equations, right? We have, x, y, z, and equals something. And we've got 3 of these equations, right? We've got all these equations. We need to solve for x, y, and z. Some of you guys are feeling the pain right now of having to do 3.4, right? 3.4 is taking a lot of work because you're doing a ton of algebra, and if you mess up one thing, it messes everything up. What we can do is we can use the power of matrices to solve this kind of equation. So let's actually just go ahead and do an example from your homework. Okay, so Number 31 is a problem that you have to do. Okay, so we have 6, this is on page 219, and this is number 31. Okay, we have 6x plus y equals -2, and we have -x plus 3y equals -25. Now, I know that for this particular equation, there's two equations and 2 variables. I know that for this particular one, using matrices might not necessarily make it look easier right off the bat. But the idea is if you know how to do this for 2 equations and 2 variables, you could also do this for 5 equations with 5 variables. So instead of giving you the 5 equations with 5 variables, we'll do it with a 2 equation, 2 variable one, even though I know that there's other methods that might be easier for this particular one. Okay, so what we can do whenever we have any number of equations that have variables is that we can actually transform those into a matrix equation. Okay, so what we're going to do is we're going to take basically the coefficients. So I know that we talked about this in Algebra 1 one day, long time ago. The coefficient is just basically the number that's out in front of the variable. Okay, so we create a coefficient matrix. So we say out in front of x is 6, out in front of y is -1, out in front of x is 1, and out in front of y is 3. So this is our coefficient matrix, and we multiply that by the variables, x and y. Then we get our results, -2 and -25. Okay, so this is a different way of writing this system of linear equations. So just to kind of prove it, if you multiply this back out, right, and I'll have to erase this after I do it, but if you multiply this back out, you have a 2 by 2 matrix times a 2 by 1 matrix. You're going to end up with a 2 by 1 matrix, right? And you're going to get 6 times x minus y. That's our first row, first column. And our second row, second column is going to be x plus 3y. So I just wanted to prove when you multiply that back out, you end up with these same 2 equations. All right, let me do a little erasing here. Okay, so everybody okay with rewriting our linear equations as a matrix equation? Or sort of okay-ish with it, at least. Elijah, you crack me up. But are you sort of following for now? Okay, so now I want you to remember your just basic algebra, right? If you have 3 times some number, 3 times x equals 9. How do you solve for x? Well, usually you just divide by 3, right? And you're done. Well, with matrices, we can't divide by x, but we can't divide by the matrix, but we can multiply by the inverse. So another way to solve this, right? 3 times x equals 9 is we can multiply both sides by the inverse. Okay, so 1/3 is the inverse of 3, and 1/3 times 3 just leaves you with 1, and we can solve that x equals 3, if I do my math right. Okay. Another way to write an inverse, another way to write this is 3 to the -1 power. Have you ever seen that before? Maybe on your calculator you've seen that. This means the same as 1/3. So it's multiplying by the inverse. That was a really, really long way to say that okay, we do this over here on the right-hand side for algebra, right? We can do the same thing for a matrix. So instead of, what we're trying to do is we're solve for x and y, right? Or x, y, and z, or w, x, y, and z, whatever number of variables we have. So in order to get x and y by itself, just like we do in the algebra equation, right? One of the things that we can do, instead of dividing by a matrix, which we're not allowed to do, is that we can multiply by the inverse. Okay, so what that means is we're going to do 6, -1, 1, 3, and then we're going to multiply it by the inverse, which we haven't even calculated yet, right? But it's the inverse. It's that -1 times xy. And if we multiply one side by the inverse, then guess what? We have to multiply the other side by the inverse. So 6, -1, 1, 3, the inverse times -2, -25. So when you multiply a number by its inverse, you end up with 1, right? Well, over here, when you multiply a matrix by your inverse, you also end up with 1. So we're left over with x and y equals the inverse of our original matrix times the sum, the end result. Now, we spent some time on Monday talking about how you find the inverse and all that kind of thing. But what I want to show you is that if you use a calculator, that this can be really powerful. So let me try to minimize this so I can actually see what's going on. So let's clear everything off. I guess that's how you do it. Clean everything up. Okay, so my original matrix, right, was 6, -1, 1, 3. And then my answer was -2, -25. Okay. What I'm saying is that, let me move it around. I'm saying that x and y, not what I was trying to do. X and y equals the inverse of A. This is our matrix A, right? The inverse of A times B. So I label this A and B, and I'm saying that x and y equals the inverse of A times B. So if I switch back to my calculator, I have xy is going to equal the inverse of A, that's how you would write the inverse, times B. So let's see what happens. The inverse of A is 6. Did I write something wrong? That's crazy. 6. Oh, I wrote something wrong. This should be a +1. And this should be -1. There we go. Hopefully that's better. That's much better. So always check what you wrote down, right? So the inverse of A, you can see this is our original matrix A times it's to the inverse power, times B equals 1, -8. So if I switch way back over to my crazy paint, let's try to write it in red so we can see. What were my numbers again? See, short-term memory. 1, -8. 1, -8. So that tells me that x equals 1 and y equals -8. And then we could always go back and use one of our other methods, like write Desmos or something like that, to prove that those are the x and the y that are true. Okay, did I lose everybody, or is it starting to sink in a little bit? What we're trying, the ultimate goal, I'm kind of trying to get to the ultimate goal here is that we want to be able to solve equations using matrices. Not sinking in. It's floating right there on the top. Oh, I don't know what that means, Daniel. Is it sinking? Oh, I am recording it, Greta, at least. All right, Caitlin, James, and Mackenzie, what are you guys thinking? Oh, good. So what I thought would be actually interesting to do would be actually to pick one from 3.4 that you guys are doing all this crazy work for and see if we can use matrices to solve it. Wouldn't that be fun? Fun. All right. I got one fun, so that's enough. All right, so I'm going to go back to page, I think we did number 15 already. I'm going to go to page 182, and we are going to do problem number 17. But instead of taking an entire page of paper to do it, we're going to try to use matrices to solve this. Okay, so we're on 182. This is number 17. This is where you used a lot of paper to solve this. 4x plus y plus 5z, not minus, my pen's not working, plus, there we go, equals negative 40, negative 3x plus 2y plus 4z, if I can get my pen to write, equals 10. And x minus y minus 2z equals negative 2. Oh gosh, Elijah's telling me he fit all his problems into tiny little squares. I have to get out my not binoculars, it's the opposite. Magnifying glass, that's what I'm looking for. I'm gonna get out my magnifying glass. Okay, so what we have here is we have 3 equations and 3 variables. So we're gonna transform this into a matrix expression that we can solve. Okay, so what we do is we have one matrix that's going to hold all of the coefficients, which are basically the number before the variable, and then we're going to multiply by the variable and get the solution. Okay, so the variable is x, y, and z, right? In my first equation, the coefficients are 4, 1, and 5. Okay, so that's whatever's before. My next row, the coefficients are going to be negative 3, 2, and 4. And then my last equation, my coefficients are going to be 1, negative 1, negative 2. And then I have my matrix over here, what it equals to. It's going to equal negative 40, positive 10, and negative 2. Okay. So what I'm trying to figure out, right, with all these problems, first I'm going to double check my work before I keep talking. Okay, negative 3, 2, 4, 10, 1, negative 1, negative 2, negative 2. Okay. what I'm ultimately trying to do, whether I'm in section 3.4 or I'm in section 3.8, is I'm trying to find what x, y, and z are, right? I'm trying to figure out what makes all three equations true. So I need to get x, y, z equals something, right? And in order to do that, I need to get rid of this matrix, not get rid of it. I need to move it to the other side of the equation, right? And the way that we can do that in algebra using matrices is we can multiply by the inverse. And we spent some time figuring out how to find the inverse, but we can multiply by the inverse, right? So let's just really keep it simple. If this is matrix A, and this is my big X, my unknown, and this is matrix B, right? I can say, okay, I'm going to do A times the inverse of A times X, but then I also have to do the inverse of A times B on this side, right? If I multiply one side by the inverse, I have to multiply the other side by the inverse. And just like in regular algebra, when you multiply a number by an inverse, when you multiply a matrix by an inverse, you just get 1. So ultimately, that tells me that X equals the inverse of A times B. Okay. I could figure out what the inverse of A is and multiply it by B, but that's going to take us way longer than the next 15 minutes that we have. So what we're going to do is we're going to use a calculator to help us determine the inverse of A times B. Okay. So let me minimize a little here so I can clean things off. Okay, so matrix A is going to give me 4, 1, 5, -3, 2, 4, 1, -1, -2. Okay, and let me scroll here. Won't let me scroll over. There we go. And matrix B is, I'll just look on my book, -40, 10, and -2. Okay. So what I am ultimately trying to do, remember back here, I have my first matrix times my unknowns times B, and I want to figure out what my unknown X, Y, and Z are, right? And in order to do that, I'm going to do the inverse of A times B. If I go back here, thankfully this is the default calculation that's in here. So I want to take the inverse of matrix A times B, and I get that X equals, well, the inverse of A times B equals -6, 4, -4. So that means that X equals -6, Y equals 4, and Z equals -4. Let me read your answer in 1 second, Elijah. I want to give you one note though. Do not try, well, if you do try it, you'll figure it out really fast. You can just find the inverse just by doing this. So it'll show you the inverse, right? But if you try to do instead B times the inverse of A, the calculator is going to tell you the number of columns in the first matrix should equal the number of rows in the second. So don't do that. Okay, you have to actually do this in a particular order. So you have, because of the rows and the columns, right? You have to multiply the inverse times second. Okay, Elijah says, couldn't you figure out what XYZ is by multiplying them together and dividing that sum by their respective answer? Unfortunately, no, Elijah. The two ways that you can figure out what X, Y, and Z are to do a bunch of substitution and elimination, right? That's what those of you that are still working on your 3-4 homework, you're trudging through solving these. No, you can't use the matrices to solve 3.4, unfortunately. Or you can use it to check it now that you know, right? But you can also look in the back of the book to see. Um, or you can put those into a matrix form and then you're able to solve. So I want you to just, I want you to kind of give me your feedback. Does this make sense? Like that you can use a matrix and it's really powerful to help you solve equations? And I'm not just pulling random numbers out of the air. There's actually a reason. Awesome. Okay. So the last little part, I just want to show you one more time is there is a matrix calculator. This makes sense. I still have no idea what the practical use. Well, the practical use, there's actually a lot of uses. One is in a lot of data analysis. Like if you think of like any type of data where you're coming up with a huge Excel, you've got like thousands of rows of data and you need to transform that data. What you're doing a lot of times is you're doing matrix calculations. You don't actually use it. I can't think of anything in your daily life, but there's a lot of applications in math and science where you can use matrices. And that, like I said, there's a lot more that you can do with matrices that I don't even know. I mean, I know what transposing and that kind of thing is, but there's a lot of powerful data analysis that you can do using matrices. All right. I wanted to show you one last thing because I know it's on your test. And I asked you to try without a calculator. And that is to find the determinant and the inverse of a matrix without using a calculator. And I'm only going to ask you. All right. I've never heard of that happening, but I'm only going to ask you to be able to find the determinant and the inverse of a matrix if it's a 2 by 2. Anything bigger than a 2 by 2 matrix, I think it's just a lot of work. I mean, it is a lot of work, but it's kind of a lot of unnecessary work. So let's just review that really quickly because like I said, I know there was a question or two on your test. So let's take a quick look at that. So basically, we did all that work, right? Because we figured out, oh, if we get a matrix, we can solve for what test? The test I sent out, silly. Chapter 3 test. I think I attached it. You have to tell me if I didn't. Like I said, I sent it out Tuesday, so that was like election day. So maybe my brain was elsewhere. So ultimately, right, in that last example, we said X is equal to the inverse of matrix A times matrix B, right? How do we figure out the inverse of a matrix? So we have to figure out the definition of the inverse of a matrix, okay, is 1 over the determinant of A times D negative B negative C A. And the original matrix A is going to be A, B, C, D. Oh, okay. I guess I sent it on, I did send it on the 7th. Sent on the 7th at, I don't know what time, sometime. It's not due this week. It's due next week. You still have some time to digest this information and take the test. Okay, so let's really quickly do an example with this, okay? All right, so I'm trying to find one that you actually have to do. Okay, number 5. We have a matrix. And like I said, I will only ever ask you to do this for a 2 by 2. Anything bigger than that, we can use our calculator for. Okay, so what you have to do to find the inverse of this matrix is you have to find the determinant. The determinant of this matrix is actually really easy. What you do is you multiply this way. So you do, the determinant is going to be 6 times 2 minus 2 times 5. So 6 times 2 is 12. 2 times 5 is 10. So the determinant of this matrix is 2. Okay, so then to find the inverse of matrix A, which we're calling this one A, we're going to do 1 over the determinant, which is 2, and then we switch some things around. Okay, so we switch actually the position of 6 and 2. So it becomes 2 and 6. And we make these two negative. So this becomes -2, -5. Okay. Now, I'm running out of space. Surprise, surprise. Determinant. Det is the determinant, not the crazy strong bug spray. That has 2 E's. Okay. So now we're almost there on finding the inverse. This is just a scalar multiplication, right? So you're going to multiply 1/2 times each of these items in here. So we've got 1/2 times 2. It's like basically like distributive property, right? 1/2 times 2 is 1. 1/2 times -2 is -1. 1/2 times -5 is -5 over 2. And 1/2 times 6 is 3. So boom, you found the inverse of A. Okay, and I'm fine with you checking your steps on the calculator, right? I want you to know how to do it, but there is a calculator to check your work. I know that it's out there. Okay, so this, we don't actually care what matrix B is. We're just dealing with matrix A, right? So our original matrix was 6, 2, 5, 2. Did I write that right? 6, 2, 5. Yep. Okay. So you can actually find the determinant. So the determinant is 2. And if I go back here, oops, that's not what I meant to do. If I go back here, oh, the determinant is 2. I kind of erased it. Okay. And then if we want to find the inverse, you can just hit find the inverse, right? So the inverse is 1, -1, -5 over 2, and 3. And when we found the inverse by hand, we got 1, -1, 5 over 2, and 3. Oh, determinant. Yeah, all right. The determinant, Elijah, is just what you do to find the determinant of a matrix is, so this is my matrix A, B, C, and D. The determinant is going to be A times D minus B times C. So that's how you find the determinant. All right. So it's a lot to digest. It's a lot. Once you start practicing, hopefully it'll start to make sense. No. Hopefully it'll start to make sense. If you have any questions or you get stuck, let me know. I did record this, so if you need to go back and look at something, how do we do that? It should be out there on YouTube on the channel. But even if you have questions, even on Monday, just let me know. All right. Thank you guys for sticking with me. I really appreciate it. I know this is a little bit challenging, but it's actually really powerful once you figure out, oh, I can use this for a huge matrice. All right, you guys, I hope you have a great weekend. And we will see you guys on Monday. Thanks for keeping me laughing. Yeah, it's fun until you have to do it, right? Hey, at least you know there's a calculator that can help you out, right? And then say, oh, you have to know how to just, yeah, how to determine the inverse of a 3 by 3 matrix. That's a whole nother level. All right, let me stop my